Okay, we'll get started. In this section, we're going to be looking at 7b, which is Ohm's law. So the point of this section is really to look at circuits, but look at them more mathematically. So we're going to start by looking through a table of basic circuit quantities. So the first one of these basic circuit quantities is going to be voltage. Voltage. It's going to have the variable V. And what voltage is it's an electrical pressure that allows charges to move through a circuit. So if we look down at our circuit diagram right here, we see a circuit. There's going to be this element right here, maybe a battery or an outlet that's going to cause an electrical pressure that's going to push charges through the circuit. And again, those charges are going to be electrical charges. And the unit for voltage is going to be the volt. So you might see like 5V. So that's 5 volts. The next quantity is current. Current. It has the symbol I, and current is the amount of charge that moves through a wire or component in a given amount of time. So voltage talks about how much pressure there is pushing those charges. Current actually talks about how many electrical charges are actually going to flow through the circuit. And that's going to have the unit of amperes or amps. So you might see, like on the circuit right here, it says 5 or 6A, so that would be 6 amps. And the last circuit quantity we're going to look at is resistance. Resistance. It's going to have the symbol R. And resistance is a measure of how much a component resists or opposes current. So current being the flow of charges. So it's going to have the unit ohms. And the symbol for that is the little horseshoe. So that's omega. So if you see something like this, 2 horseshoe, right, 2 omega, that's going to be 2 ohms of resistance. So those are the 3 important circuit quantities. The next thing to think about is a couple smaller things. So voltage, when we look at voltage, again, I said it before, but voltage is going to be applied to a circuit by a battery, an outlet, or it could be another electrical source. So there has to be something behind that electrical pressure to supply that voltage. The next thing that's important is Ohm's law. Ohm's law. And that's going to be a mathematical law that relates voltage, current, and resistance. This is the law right here. V equals IR. So the voltage is equal to the current times the resistance. That's going to be Ohm's law, and we're going to be using that a lot to calculate specific quantities of circuits. So it's important to keep in mind that a lot of times when you build a circuit, you're looking for a specific amount of current, and you're often going to adjust the voltage, adjust the resistance to get the amount of current you want. And remember, so more current means more charges. So if we have more current, you're going to get a brighter light, you're going to get a faster motor. So whatever you're powering, more current's going to make it do more of that thing, basically. Okay, next part of the notes. Where is it? Here we go. So the next part of the notes, so we already did this right here. I'm going to pick up. So again, sometimes it's helpful to rearrange Ohm's law to just get the current by itself. Again, it's the same law, but sometimes you'll see it like this. So the V divided by R is equal to I. Again, just a rearrangement of the same thing. And the last couple terms right here. So voltage is going to be highest at the positive terminal of the battery, where there's going to be increase in voltage, or we'll call it a voltage gain. So if we have the circuit right here, right, the longer end is the positive end. Basically on this side of the circuit, the charge is going to flow this way. You're going to get an increase of voltage. You're going to get a voltage gain right here from the battery or the outlet or whatever. And it's also important to keep in mind that voltage gain that's caused by the battery has to be reduced by 0. So again, it'll be 12 volts over here, right at the positive terminal, but by the time it goes all the way through the circuit to the negative side, it has to make its way back to 0 volts. So again, it has to be dissipated, really. And the last part, the voltage, so we talked about voltage gain, now we're going to say the voltage drop across a resistor is the decrease in voltage that happens between the beginning and end of the resistor. So if we look in the circuit, the outlet, it provides a voltage here, let's just, 12 volts. And you're going to have a voltage for most of that circuit until you run into this resistor. And the resistor, what's happening over the course of the resistor is it's actually bringing that voltage down. There's going to be a voltage drop across the resistor, and it's actually going to be 0 volts by the time it hits the other side of the resistor. So that's important to keep in mind. Whatever voltage gain there must be, it must be dropped by the time it gets back to the other terminal, or the other side of the battery or outlet. Okay, so that's all of the stuff for 7b. So again, the 3 circuit quantities: voltage, current, and resistance. Ohm's law, the idea that you can calculate you can calculate other circuit quantities you'd like, and then the idea of voltage gain and voltage drop is really all the main ideas here. Okay, in the last part we're going to look at a problem. So we'll see a problem similar to what you'll see in the future. Here we go. So in this problem, make sure you take an attempt to solve it before you see me solve it. Again, make sure you're attempting the problem first. Okay. So what we have here is a 20 ohm light attached to a 120 volt outlet. Alright, and it's asking us how much current is flowing through the light. So it doesn't ask us to, but let's draw a picture. We have the outlet. We have a light, which we're going to just draw as a resistor because it's something that resists the current to do something. So we have a 120 volt outlet. This would be the positive, this would be the negative, and a 20 ohm resistor. So it's asking A, how much current flows through the light. So to do this, we know the voltage provided by the outlet, we know the resistance. So we can use Ohm's law. So we know the voltage, we know the resistance, we're looking for the current. So we're just going to plug in, we know it's 120 volts. We're looking for the current, and we know the resistance is 20 ohms. So fairly straightforward. We'll get out the current as 6 amps. So again, make sure to use all the proper units. B, it's asking what's the voltage gain from the outlet. The voltage gain, right, is what's the outlet supplies to the circuit. And if we look here, it says, it's 120 volts. So it's going to provide all 120 volts to the circuit. So that's going to be the voltage gain, will be 120 volts. The last part is what's the voltage at the negative end of the negative terminal of the outlet. So we know what's going to happen by the time it reaches the negative terminal. So we look from the notes. So you get a voltage, whatever voltage supplied must be dissipated by the time it hits the other side of the battery. So in the negative terminal, it's actually going to be 0 volts. And then it's asking, in the last part, what's the voltage at the positive terminal? So the 0 volts right here, and at the negative terminal, but what's at the positive terminal? So if we think back, at the positive terminal, that's really where the voltage is beginning to be supplied. So you're going to get a voltage gain is really all going to be experienced on the positive side. So on the positive side, you're going to get the full 120 volts. And that's as it goes, as you look at the circuit, it's going to be dissipated by this resistor, and then it's going to go to 0 at the end. So 0 volts and then 120 volts. Okay, so that's the idea. That's really all the basics behind Ohm's law.